Hello guys, in the next tutorials we'll be making some enemies, just like Andres Quellar asked for. So let's get started. In this tutorial I'm going to make a little face that follows the player around. So I'm going to drag the sprites into here and transform them. So put them into multiple and make it to point, and in the sprite editor put it into a grid of 20 by 20, like so. Apply. And now to drag the face into here, and as you can see it's a bit too small, so I'm going to change the pixels per unit to 20. Hit apply, and as you can see now it's big enough for us to see it. And I'm going to edit a collider. It can be a box collider or a circle collider, or even both if you want. Do however you want, and just adjust it to be kinda like that. And now let's add a script to it. So add component, new script, follow script, follow. And this will follow something. It can even be something different from the player. So first, to make it follow something, we have to know what is it following. So public game object target, which is what it is following. And because most of the times this will be the player, so that we won't have to add the player as the target, I'm going to put here if target equals null. Meaning if we haven't filled this in the inspector, then I want the target to be equal to game object dot find with game object with tag player, just like that. And now to make it follow something, there's actually a very simple function that Unity gives to us, which is move towards. So what I'm going to do is make transform.position equals vector 3. And I'm going to put vector 3 instead of vector 2 because there's some issues with compatibility, but it will work all the same. Dot move towards, and this is the function. And as you can see, it requires two parameters: the origin parameter, the target parameter, and the ratio that we want it to follow. So the current is a transform dot position of the face. The target will be the target dot transform dot position. And the ratio, or the step, or whatever you want to call it, will be a ratio that will be a public variable. So I'm going to put here a ratio, public float ratio, and initialize it at 0.05 float. Save, and you'll see that if I play, that this will put here the player automatically, and it is following it, and that's basically it. But for now it doesn't do anything to the player other than just pushing it away. And I'm going to make it collide with the player, but not collide with the other stuff, so just make it a trigger and make it deadly. And now you'll see that every time it collides with the player's lives will get down. And why is that? Well, because of like 1,000 tutorials ago we did this thing over here in the simple player 0 script, where if something collided with the player and the player wasn't dead or immune, then the lives will decrease, as you can see. And if the lives were 0 or 1, the lives will be 0 and the player will die. So that's why that deadly tag works. Anyways, we could stay for here, but this is not very interesting. So what I'm going to do is, just like in many games, I'm going to make the face move faster whenever the player isn't facing it. And the way that we're going to do this is using the dot product. So let me show you. There's a lot of tutorials on how to use the dot product. This is just the simplest of capabilities of the dot product. Okay, so this is basically a web page that shows us the dot product within this for these determinate vectors. So these are two vectors, the red one and the blue one, and as you can see while they are pointing into the same direction, they are positive. But if they are perpendicular, then they are 0. And if they start pointing in different directions, which is if they between them they have more than 90 degrees, then the dot product is negative, as you can see. So, and we're going to use this. So those two vectors will be these two vectors, and as you can see, if I put them in the same place, it will be something like this. So this is the vector that points from the face to the player, which is basically the transform dot position of the player minus the transform dot position of the face, and this is the direction of the player. And if we put those vectors in the same origin point, then they'll point in the same direction because they have less than 90 degrees between them. And if they do point in the same direction, it means that the dot product will be positive and that the face should go at a higher speed. So let's do that. So here in the follow script, we are now going to check for the dot product. So here, if vector 3, and again we're going to use vector 3 because of some compatibility issues. It asks for two vectors, and I'm going to put the vector that points from the face to the player. So target dot transform dot position minus transform dot position, and basically if you do the final point minus the beginning point, it will point like that, and the other point is just the direction of the player. And just like we did in many other tutorials, all you have to do is to make target dot transform dot local scale dot x times vector 3 dot right. And the way that this does is, by default, the player is facing the right always, but if for some reason it turns to the left, then this value is -1, and this whole vector will mean vector 3 dot left. Okay, and that's done. And we're not, like I said, if this is positive, then it's because the player is facing the same direction, of the face, so we want the face to go faster. So I'm going to put here a variable only for this function, which will be a float step. I could actually also put it there, but it's the same thing. So here I'm going to put the step be equal to the ratio times 2. Okay. Else I want the step to just be equal to the ratio. Save. And I forgot a parenthesis there, and here I want to put step instead of ratio, because right now what we are changing is the ratio. And let's see if this is working fine. Hopefully it is. So right now this is the velocity, and if I turn away, as you can see, it goes much faster. I die almost instantly. So I'm going to decrease the ratio a bit so that I can actually escape the ghost. And as you can see, it goes a little bit faster whenever I turn away from it. And that's basically it. Now I'm going to change its face whenever it's running, whenever I'm not facing it. So just put here public sprite array called sprites, and we want to change the sprite render, meaning this. We want to change the sprite render dot sprite of the face to be between these two sprites. So whenever we don't see it, it will be, whenever you are facing away, it will be this sprite, but whenever you are facing the face, it will be this sprite. So let's click on the face, go onto the sprites, put it with size 2, and drag the normal one to here and the scary one into here. And now, just like I said, here I want to change the component of the face. Here I want to change the sprite render of the face. So get component sprite render, and I want to change the sprite, so dot sprite equals sprite, and this is the element 1, else we want it to be with the face 0, just like so. Okay, and that's it. As you can see now, it opens its face whenever we are turning away. And that's cool. Now the next thing that I'm going to do is to give the face a radius, because right now no matter where we are, the face will always go towards us, but if we are a bit far away, the face shouldn't be able to detect us. So the way that I'm going to do is to make a circle cast around the face that will check if the player is there or not. So I'm going to put here a variable, a bool, called got which turns true whenever the face found the player, and will start following it. So anyways, here in the update function, if got is false, then every time we go into here, like I said, I'm going to use a circle. So I said the circle cast, but actually what I'm going to use is an overlap circle, and that if I do here physics 2d dot overlap circle, and I'm going to use all, which gives us a collider to the array of all of the colliders this circle collides with. And probably if you go into the Unity reference, you'll understand better, and just read this page. Okay, anyways, this circle asks for a few components. So the first one is the point. So the point will be wherever the face is, so transform that position. And the radius will be a radius that you know, if you want, you can change. I'm going to put here public float range, so that you can change the radius if you want. So range, like so. And like I said, this returns a collider to the array. So I'm going to put here a collider to the array called hits equals that. Okay, and now we have to cycle through all the elements in this array and check if any of them are tagged player. So for each collider to the in collider to the age in hits, so we are checking if the age dot game object dot tag equals, and actually instead of making it through a tag, because sometimes the whatever we are chasing may not be the player, I'm just going to check if age.gameObject equals the target. So if it is equal to the target, it means that we have to chase it. If it's not, we don't have to chase it. Okay, anyways, if this happens, got will be true. Got equals true. And we can actually also break out of the cycle, because if you got it, we don't need to get anything else. We don't need to check any other collider, so just put here a break, and what the break does is it cuts out of the for each loop or any other loop and goes to the next part, so over here. And for some reason I didn't put it inside this if clause, so just put it inside the if clause. My bad, sorry guys. Okay, and now only if got it is true, it will do this. So, and also this, so put here if got it is true, then it will do that. And so that we can see actually the radius of this circle, I'm going to put here a void on draw gizmos, so that we can see the gizmos and see a circle. So gizmos dot color equals color dot something. I will need to put white, and gizmos dot draw wire sphere, and the sphere, just like we did in there, the center is transformed by position, and the radius is the range. Okay, save, and hopefully it should be working. So let's see, let's check. Okay, so right now the range is 0, so it isn't detecting anything at all. But if I make the range bigger and bigger, as you can see, it's checking in all of that area if the player is there. And if the player is indeed there, then it will start chasing the player forever, even if the player gets out of the box, because that's the way we did it. And that's basically it. Now the only thing that's left is to make a way for this to die, and all you have to do is to make a void on trigger enter to D. So whenever void on trigger enter to D, and we have to check whatever collided with it. So collided to the other, which is whatever collided with this trigger, if other dot tag equals projectile, and this is actually on our furballs. So here in the prefabs, the furball is a projectile. If other dot tag equals projectile, then I want to execute the die function, public void die, and in this function what it will do, it will destroy this outcome object after some time and instantiate an explosion at transform.position with 0 rotation, like so. And I'm going to create that explosion right now, public game object explosion. And I can actually also make this die if the tag is equal to the player tag, so, or if the other dot tag is the player, and let's create that explosion. So Control Shift N to create a new game object, name it die explosion, something like that, and give it a component which is a particle emitter, particle system. And as you can see, now it does that, and you can change the renderer to, instead of just throwing these weird circles, throw anything else you want. I'm going to stick to these squares over here, and I'm going to put the duration at 0.5, and the emission I want it to burst at 0 seconds, like 10 particles or 100 particles. And they are a bit too big, so I'm going to change the size to be a bit smaller, like that, and the speed to be a bit bigger. And now let's make it not loop, and if I stop and simulate, that's the explosion. And I can make it go a little bit faster. Okay, and but the particles stay in the scene way too much time, so I need to also change the lifetime to be a little bit smaller, so maybe 1 second, like that, and then they disappear, and that's fine. And I'm going to also add a component which is a script called destroy by time, which basically destroys this after some time, and I can put here 2 seconds so that it destroys the explosion. And anyways, I'm going to drag this into the prefabs, and also going to the enemies, and find the explosion prefab, and drag it into here, delete it from the scene. And now if I throw a furball into the face will explode. And also if I go head first into the face will also explode. But as you can see, we haven't lost lives, and that's because sometimes the face dies even before the player gets to lose lives. It's because we destroyed it so quickly that it didn't have time to execute this function in the other game object, meaning in the player. So what we're going to do is just wait a bit before we delete it, so like so, something like that. So only after 100 milliseconds it will destroy the face. So right now, as you can see, we have time to change to lose a life, and the face dies almost instantly as well. And that's basically it. So thank you for watching this tutorial, guys, and see you in the next one.